Hey guys, this is DG Makes Math Easy, where we are intentional about making math dimensional. I'm Donisha Gordon, and today we'll be focusing on indices. Now, this video was specially requested by Alia Gordon, so big up Alia. Guys, don't forget to share with your friends. Don't forget to like and subscribe and leave comments as to which videos that you might want to see next. All right, we'll get straight into it. Before we go to our CSEC questions, we will go through the basics, the rules that you need to know when it comes to the law of indices, same thing called the law of powers or law of exponents. All right, so we'll be doing about 7 to 8 laws. And after that, we'll go straight into the CSEC questions. All right, so we're going to take a look. I'm going to hope that you know how to multiply variables. Let's take, for example, a cubed times a to the 4th power. Now we know that a cubed means a times a times a, and we're multiplying that by a to the 4th power, which is a times a times a times a. Our final answer would be a to the 7th power. And this brings us to law number 1. Now, for every question you get, you will not be doing this. You would not be writing out, you would not be expanding a cubed and a to the 4th power. And so we can take a look at, we can pick up a pattern that says, and you can try it with other terms, that says if we are multiplying same base, and this letter here is called the base, 3 and 4, those are the powers. All right, if we're multiplying same base, then we can add the powers. If you notice, 3 plus 4 gives us 7. And so law number 1 is going to look like this. All right, I'm going to have to, okay, law number 1 will look like this. If I'm raising a to a certain power times a raised to another power, then I can go ahead and add the powers. All right, so that's it for law number 1. And we are going to move to law number 2. You can always pause. You can always pause and take notes if you wish. All right, here we go. Let's take a to the 5th power divided by a cubed. And let's look at it like this. I'm gonna need a little more space. A to the 5th power divided by a cubed. We're gonna rewrite this in fraction form. So that's gonna be a to the 5th power divided by a cubed, and we're going to expand. All right, all of that is being divided by a cubed. All right, and if we should simplify here, we will get a into a goes 1 time, so we have a canceling a canceling a again, and our final answer is a squared over 1, which is a squared. And so we can pick up another pattern for law number 2. That says if I'm dividing 2 terms that have the same base, I can go ahead and subtract the powers. 5 minus 3 gives me 2. So let's use just some variables so we can keep it general. Dividing same base, we can go ahead and subtract the powers. All right, that takes care of law number 2. You can pause, you can write. Law number 3, let's take a look at a to the 3rd. Let's not keep it locked into that. We can go ahead and try different variables. Let's say d to the 4th power, and I am squaring that. What does it mean to square something? We multiply it by itself. So this is really d to the 4th power times d to the 4th power. And while we wouldn't have to expand each of those, we know that there's a rule, law number 1, we looked at, that said if we are multiplying same base, then we can go ahead and add the powers. And so this would have been d to the 8th power. But then if we look a little closer, we will notice that the powers are 4 and 2. And if we multiply those two, then we would get 8. You can try with other, examples. That's fine. You will realize that the rule works just the same. Just try this again with different powers. All right. So if we say if you are raising a power to another power, then you can go ahead and multiply the powers. So let's keep it a little bit general. A to the power of m, and we're raising that to the power of n. We can go ahead and multiply the powers. And that would be law. I'm going to just squeeze it right here. Number 3. We will now move to our fourth law, and we're going to take an example looking like this. B to the 5th power divided by B to the 5th power. Now you can do one of two things. You can say any term divided by itself will give you 1, so we're sure of that. But if we also look at b to the 5th power divided by b to the 5th power in terms of the rule we encountered earlier, which would have been, since we're dividing and the bases are the same, we can subtract the powers. That's 5 minus 5. So that would be b to the power of 0. Then we can now assume that b to the power of 0 is equal to 1. And you can try other examples, and you will realize that any number raised to the power of 0 is also equal to 1. So that is our fourth law. Any variable or any number raised to the power of 0 gives you 1. All right. We move to law number 5. Let's take, for example, x to the 4th power divided by, or let's take x to the 6th power divided by x to the 9th power. We know that we are dividing, the bases are the same. We can go ahead and subtract the powers. So this would have been x to the 6 minus 9, which is equal to x to the power of -3. Okay, and then we will now say, let's look at it a different way. What if we were to expand, sorry, x to the 6th power. Let me just clean that up. Divided by x to the 9th power. I hope it can all hold. So that would have been x times x times x. Of course, you will not do this. This is just for our demonstration. 1, 2, 3, 4, 5, 6. And let's hope that we can have 9 of them holding here. Okay, there's going to be like 1 left off. Unless they allow my screen to. Beautiful. All right, and if we should simplify, x into x goes 1 time, etc. Oops. All right, here we go. Good, we now have as our final answer 1 over x cubed. 1 over x cubed. Let me just clear the screen and just write it, and just rewrite. Okay, so when we did it, well, for both ways, we got 2 different answers, 2 different looking answers, but these are actually the same. All right, so we did this little exploration just to prove that x cubed, x to the -3 would have been the same as 1 over x cubed. And so the general law that we're going to write at this time, I think this is about law number 5. All right, is going to say if we have a variable, a number, if we have something raised to a negative power, it is, that's not written properly. Let's use n, any number. All right, then it is the same as 1 over a raised to the positive of that power. And in the same way, if we have a to the n, it's the same as 1 over a to the -n. You can picture, you can go ahead and picture a to the n over 1. So you can look at it as a fraction. and you probably will be better able to see that. I don't like what this. Okay. Good. The sign of the power changes if the term is alternated between the numerator denominator. All right. And then we go to another law that says, all right, let's take a look at this. Let's look at 9 to the half times 9 to the half. Now we know that since the bases are the same, we can go ahead and add the powers. So that's 9 to the half plus half, which is 9 to the power of 1, which gives us 9. Now, question to you, what number can I multiply by itself to give me 9? So here we notice I multiplied something by itself to give me 9. And if I multiply a number by itself to give me another number, then it means that this would be the square root of that number, which means I can also say that 9 to the half means square root of 9. Square root of 9 times square root of 9 would have been 3 times 3, which would also give me 9. So my sixth law, I believe, will tell us that if I raise a number to the half, it also means that the square root of that number, square root A. All right, but let me generalize it a little bit by saying that if you can also use other numbers and you'll find the same thing with this, with the cube root of a number. And so let me generalize the fact that if I have, okay, I'm gonna need a little space here. All right, a to the power of 1 over a particular number, it means, and if that particular number is n, then it means I'm finding that root for the number. All right, so this is our law number 6. And I'm just gonna call this 6A. 6A as we move to look at another half of this law. All right. All right, let's take A to the 1 over n, and I'm going to raise that to the power of m. So earlier we looked at a law that says if we have something raised to a power and I'm raising that term to another power, then I should go ahead and multiply the powers, which means this, and I'm putting 2 equal signs in one line because of space, right? And this means this is the same thing as a to the m over n, as that's what we would get when we multiply 1 over n by m. All right, so this law, part 6b, would tell us that if I have a to the m over n, and I'm going to just use another ink here, we would remember that this n represents the root of a. So this, or original statement, would mean that we are raising the square root of n to the power of m. All right, so you can take this off as our 6th law, part 2. All right, so law 6b. All right, and then we are coming down nicely. We have just about 2 to go. All right, let's look at 2 times 3, and I am squaring that. Now, if you are following the order of operations, then you would know you work out the brackets first, and you go ahead and get 6, and if we square that, we will end up with 36. I have space. But if you were also to take another look at this expression, 2 times 3, I'm squaring that, you can also square the numbers individually. The numbers, the factors that are inside, the numbers being multiplied, we are going to square those individually and multiply them. So we're going to have 2 squared times 3 squared. That gives us 4 times 9, which would still give us the answer of 36, which means then that if I have 2 numbers multiplying by each other and then I'm raising them to a particular, raising that product to a particular power, it is the same as raising the numbers to the power individually and multiplying those. So I like to say it like this: this product raised to the particular power is equal to, I have squared. Okay, that's because I intended to put square here. Good. So this product square, so the square of the product is equal to the product of the squares. All right. So now to make it a little more general, we will write law number 7 as this. Law number 7. Bam. All right. And finally, number 8 is going to look a little bit like number 7. Let's look at 10 over 5, and we are squaring that. So 10 over 5 gives us 2, and we're squaring that, we would get the answer of 4. And if we also look at 10 over 5, look at the numbers individually, we end up with 10 squared divided by 5 squared. So we can square the digits, square the numbers individually, sorry, and we get 100 over 25, which will still give us 4. So our 8th and final law looks like this. If I have a quotient and I'm raising it to a particular power, I can take the numbers and raise to that power individually and divide. All right, so that's it for law number 8. Now we will go straight into the CSEC questions. All right, I hope that you have now been refreshed with all these laws. Stay tuned for the CSEC questions. So for our first CSEC question, we notice there's a mixture of multiplication and division. All right, and we also have whole numbers and variables. All right, here we go. 4 times 3 gives us 12. C squared times c to the 4th power. We can go ahead and add the powers. So that's 12c to the 6th power over 3. We can go ahead and subtract the powers. And if you want to show a little working there, you can. Our final answer is 12c cubed. This question says to evaluate, and we have parts A, B, C, and once you're evaluating, you're finding a final answer. You'll get a number for your answer. All right, here we go. 18 cubed divided by 18 squared. We can go ahead and subtract the powers because the base is the same. All right, which will give us 18 to the 1st power, which is 18. All right, and if you notice, I haven't left much space for part B because we know that answer is 1. 8 raised to the power of 0. For part C, we should remember that this 2 represents the root. So in essence, this is the square root of 25 and the square root, so I do not have to put the 2 there. And I'm raising that to the 3rd power. What's the square root of 25? That's 5. And I'm going to cube it. My answer is 125. For our next set of questions, let's take part A first. We have 5 to the negative 2, and we know this can be rewritten as 1 over 5 to, not negative 2, but positive 2, because it's now in the denominator. All right, 1 over, and 5 squared is going to be 25. For 49 raised to the power of a half, we know that means square root of 49, and so we can go ahead and just write 7. Done. Part C, very simple. We are multiplying same base, 6, and so we can go ahead and add the powers. We have 2/3 plus 2/3
plus 2/3. And that gives us 6 to the power of 6 over 3, which is 6 squared. And so that means our final answer is 36. Done. Pretty simple, don't? All right, moving right along, we have 4 to the power of 3/2. And so we know that this means the square root of 4 being raised to the 3rd power, which gives us 2 cubed. Final answer is 8. All right, and for part B, raising 5 over 3 to the power of -2 is the same as raising 5 to the power of -2 divided by, and we're also raising 3 to the power of -2. Now, our powers are negative. We want to work with them positive. And so right now, to make this power positive, we know we can move this to the denominator and or 3 to the -2 to our numerator, which changes the sign of our powers. So this is now 3 squared divided by 5 squared, and that's now 9 over 25. Part C, pretty easy. 2 to the power of 0 is going to be 1 times 2. Done. Now, all of these are CSEC questions, all right? So you can see how simple they are. Okay, by this time, you should be racing me to the finish line with these questions. Let's go. We are supposed to simplify this, and we know this is equal to x raised to the power of half raised to another power, so we're going to multiply by that power. So it's times 3 times. This is the square root of x to the 9th power, and so we know that we can write that as square root of x to the 9th power, which gives us x to the 3 over 2 times x to the 9 over 2. The bases are the same, and so I can go ahead now and add the powers. X to the 12 over 2, which is x to the power of 6. We're done. Before we move into our next question, feel free to pause the video at any time to make notes. All right, this question requires for us to not just know the law of indices, but to also know how to use the distributive law. So we will multiply 4a to the -half by a to the 5 over 2 minus 4a to the -1/2 times a to the -3 over 2. All right, and now we have same bases being multiplied, so I can go ahead and add my powers. So we have -1/2 plus 5 over 2 minus 4a. We also have -1/2 plus -3 over 2, which gives us 4a to the, we can just work on our numerators because our denominators are the same. So we get 4 minus 4a, this is going to be -4 over 2, which gives us 4a squared minus 4a to the -2. And we should leave our answers with positive exponents. So final answer will look something like this. Minus 4 over, and we're going to move a, and the power changes to positive. Now here, we are not being asked to simplify. We actually need to solve for x. Now, in order to solve these equations involving these powers, we need to ensure that both sides of our equation has the same base. All right, so this one is a 2, and 64 can be expressed as a power of 2. So, and for more practice, you can watch my previous video on just simply solving equations with indices. That's an additional mathematics video. I will post it in the description. Now, 2 to the power of 4x is equal to 2 to the power of 6. This simply tells us then that we can rightly assume that 4x is equal to 6. Our powers are equal. Our bases are equal, so our powers are equal. And to find the value of x, we now have x equals 3 over 2. Done. And one final equation. Now, this can get a little tricky if we don't focus. So here we go. We want to express both sides of the equation in terms of the same base. Now this has a base of 9, and for the right hand side, it won't be the simplest thing to express it as a power of 9. So we can look at the numbers and observe which other number could we use to express these two as a power of. 9 can be expressed as 3 squared, and so we have 3 squared to the power of 2x equals 1 over 27 is the same as 1 over 3 cubed. 1 over 3 cubed is the same as 3 to the negative 3. All right, and we can simplify our left hand side to be 3 to the 2 times 2x gives us 4x. And so again, since our bases are equal, our powers are also equal, 4x is equal to negative 3. Dividing both sides by 4, we get x is equal to negative 3/4. And that's it. That's our final question on using the laws of indices to either simplify or to simplify an expression or to solve an equation. Join me in my next video. Don't forget to share with a friend. It's goodbye from DG Makes Math Easy.